doesn't say anything on this one. Yeah.
All right, so slides are on Canvas since the projector is not working. They're also on the course website, so I'll just start going through the slides that you can't see, but you should all be able to see on your own screen. So about regular expressions, last time I believe Akhil talked about very briefly, stopped right there. But the whole point of regular expressions is to be able to do pattern matching easily in a text file. And so you want to be able to perfectly match text within a sequence of strings. The second slide, I believe, has a very simple example. If you just put hello, you will match what you should expect, which is the word hello. And you can have more complicated expressions. Maybe you want to match something like H0, LLO, or some other numbers, and you would have that square bracket, which denotes a set of strings that or characters that will allow you to match things with.
For the time being, do you want to do a progress check on assignment 1?
What?
Do you want to do a progress check on assignment 1 to see how people are doing with them?
Progress check. Oh, sure. Progress check on assignment 1. Any questions so far?
Who has looked at it so far? Okay. Has anyone started and been able to complete a few questions at least? Okay. Like we said, we do have office hours. Does if anyone has any problems or sees something that's very difficult to try to solve, then talk to us about it. Or we have questions in Discord. Open.
No, but they're asking us PS ops. Should we also sort them?
We don't need to sort them. You just directly use PS aux, whatever the output is. Yes.
No, I messed it up. I sorted it.
If you want to, you wouldn't.
PS aux, so you have to use PS aux and you have to pipe it into anything else. So I think sort might be a command after that. You can try to sort things, but you don't need to.
Yeah.
You should just take PS aux, whatever the output is, and goes into a pipe and then keep going.
It's all up to your interpretation. So you wouldn't lose points for that. It's just another solution. They said that they might try to send someone over, but
Okay.
they're very busy. So. If everyone is also in the Discord, then you could screen share in one of the general channels. And
Can you take your laptop and see if yours works? All right. Okay, so continuing on the regular expressions, we're on the second slide now about regex sets. So a set is anything denoted with a bracket. So as you can see, this is a set, so anything that is denoted with this little bracket, that is a set of symbols that will allow you to match something in here. So when we said H0 to 9, ELLO, that means anything from 0 to 9 would match the string. So H0 ELLO, H1 ELO, all the way up to H9 ELLO would match that. You can also do individual things. So maybe I just want 0, 1, 5, and 9. And I'll just put these directly in the set, and then ELLO, and that will directly match that. Letters work as well. So H, maybe I want to A, E, I, O, U, ELLO, then those would match that. And you can mix and match. So this set itself could contain something like 0 to 9, A to Z, and then capital A to capital Z. So these are the three main sets that you can have that are using the dash to denote that this is a range. And of course, you can always combine individual things. So 0 to 9, A, E, I, O, U, and maybe all the uppercases. This would also be acceptable.
In a bracket, it will just take one of the elements?
It will take one of the elements, that's correct. So now the question is, if you want to have multiple elements, how would you do that? And of course, you can always chain them together. So you can you start with any capital letter as a valid word, and then maybe you have some vowels, A, E, I, O, U, and maybe you have some other letters, E, L, O, O. Right? So that would match any capital letter, and then some vowels, and then E, L, O, O. And if you want to match, I want to find something that's just text, so just lowercase strings, I would use something like A to Z. And then we can add a modifier out here to denote how many of these we want to see. So we can use, on the next slide, actually that's on the 5th side, you can see the quantifiers. So you can use these quantifiers as a star symbol, a plus symbol, question mark symbol, or this curly bracket with a number in here. Is it working?
No.
Oh.
Not even on my laptop. So, who here isn't in the Discord server? Okay, one possible way to do this is once you're doing terminal stuff, you can screen share and then
Okay.
everybody will have to just join the voice call for the time being. That's the one advantage of Discord over like Piazza or whatever, I guess.
All right, so we can keep going on with the whiteboard for now. So the star symbol means that you can match any number of these, including 0. So if I have A to Z, that means I will accept. So if I have literally just A to Z with the asterisk symbol over there, that means it could either be a blank string or it could be a string of only lowercase letters of any length. The plus sign means it has to have at least 1 or more. So that would mean you have to have at least 1 lowercase letter. Question mark means either 0 or 1 instance of that. And this means exactly this number of that. So
And without any of that, it's just exactly 1.
which, say again?
Without any of it, it's just
Without
exactly
all this, so just this means exactly 1 copy of that. So as an exercise for you, there is a way to format an email string, for example. So if maybe I want you to limit you to something, say, a valid email address at ucdavis.edu, you might say, well, the valid things, I don't think I've seen numbers in UC Davis email addresses. So it could be something like A to Z. A to Z, maybe I'll allow capital letters. And I want to have at least 1 because your email address must have something, so it's a plus. And I will write out at ucdavis.edu.
Can you see the bottom part of the chalkboard in the back?
So this would be like a valid, regular expression for a UC Davis email. Yes?
Did you close the laptop?
Whoa!
Okay.
Shadow box.
Any questions so far? And then of course, maybe now instead of modifying, iterating upon this, now I want to accept any email and not just ucdavis.edu. Any ideas on how to modify this to do that? Yes?
You will do the same thing, but then you will have whatever the pattern you're looking for
Yep.
with another plus sign.
Yep.
And then dot, and then the same thing with a plus sign.
Right. So technically, this is actually not the right regular expression. If some people have looked at the slide previous to that, where dot actually means wildcard. So this actually means that I would actually match something like A at UC Davis edu, for example. Because the dot means it could be any valid
How do
character.
you match the dot?
So you put that in a set.
Okay.
So let me erase this top part over here. So if I wanted to change this to any email address, well, we can go back over here, A to Z, A to Z,
0 to 9. Or like 0 to 9.
and 0 to 9. We have an at, and then we also allow A to Z.
You need plus first and then at.
Oh yeah, plus A to Z, 0 to 9. This one you must also have at least 1. And then you have a dot. So that's only 1. And then you want your domain name can only have letters in them. And this is also a plus.
Domain names can only have letters in them? I feel like I've seen.
You've seen domain names with
I mean, typically they're
TLDs?
I mean, TLDs, maybe not.
I don't think they have any.
Not top level domains, yes, you can have them. I don't think top level domains you can have them. All right.
Questions? Oh, you get that?
Huh?
2 questions?
Yes.
Oh.
Yeah, I think the main doesn't have dash in the UK.
Ah, yes. So you'll have to add an actual dash in here as well. I think you can just add a dash. I think you might actually have to escape the dash with this to prevent that from recognizing that as a range. Yes.
Can you wait, what's the last question about the escaping dash dot?
Escaping a dash, I believe you use a backslash. Yeah, backslash in the dash.
And
Yes.
we can use that to represent a period or dot?
A period, I believe you can just put it directly as a dot over there
In a
within
set.
In a set.
Or you can have it as backslash dot instead
Or
of having it as
yeah, or you can do that.
So you can get rid of the brackets and then just have it
Yeah,
as
this
dot.
would work as well.
Secondly, I was like to say that I think the website for this course is down.
The website for the course is down.
I'll investigate it.
Okay.
It looks very up to me.
It's up.
I'm sorry, John.
April 7th.
Okay. Then there are some other things, like as you may realize, this set over here, seems like it's a very valuable set. Like it makes no sense to keep writing these things out. So there are actually some predefined sets, like /d means the same set as 0 to 9. I think there's like /a maybe, or /c. I can't remember. But those are also like there's some shortcuts for you to represent these giant sets. Regex101.com is a very useful website for testing out your regular expressions and comparing against regular expressions. People use that all the time because regular expressions, frankly, are a pain in the ass to actually write out.
Something just came to mind. We might be able to check the lights to see if it's on or off.
It
Lights.
looks very on from the lights.
What's the third light? That's like
Just
off.
not receiving input.
Can anyone read that? Oh, we have to.
Hello. Hello.
With the projector, yeah.
Yeah, so,
We've tried to make it.
We've tried on 2 laptops so far. Connected on the HDMI, we connected the laptop button, and it's on, but
Ethan, what do you know about regexes and different syntax? Different languages have different regex syntax, don't they?
Yeah, they do. By default, people just use the PHP version, which is this default version. There are other newer, more fancier ways of expressing things that minimize these sets, so it's supposedly easier. But for the purposes of using Linux and using most of the Unix tools, we stick with the standard PHP definition of how everything works. Any questions about regex? Yes.
For the escape sequence looking ones, we do /d. Can you also add any amount of quantifiers at the end?
Yes. So you can do /d plus, for example, which is the same thing as 0 to 9 plus. Okay. All right. The next thing that, if there are no questions about regular expressions, then we can talk about some of the commands that actually use regular expressions. And I'll continue to use the whiteboard. So, as some of you may have seen, commands like grep
oh, sure, yeah, I can.
or sed, if you look at the man pages, it says there's some sort of pattern. And usually, maybe you've seen so far is we just match a direct pattern as a direct string. But all of these patterns, or even with sed, you can use regular expressions to match these complicated sets of patterns. So it's more efficient for you to find exactly what you want and exactly what you need. So that's why regular expressions are actually very, very useful. And they exist in not just in Unix tools. For example, if you write a Google form and you wanted to limit some, express, type of string that a user can input, Google form itself also has an option for you to input an exact regular expression that you want to allow.
Or if you want to use VS Code search, or a lot of Control F tools, they have a little icon that's the \***. That's the regex symbol, so you can write it to match text and pretty much anything. So VS Code or a lot of things.
Any questions about regular expressions?
Can I plug it into your laptop? Is it still on?
Huh?
Can I plug it into your laptop? Is it still on?
Sure. I'll try that. mean, it's recognizing that there's an input, but it's not actually showing that. All right, the next item of discussion is on text editors. So the most common text editor that Linux people like to use is Vi or Vim. I'll actually show you how this looks like, hopefully when we get the projector working. There's some others known as Emacs. In fact, if you Google Vim, it will ask you, did you mean Emacs? And if you Google Emacs, it'll tell you, did you mean Vim? There's a hilarious war that goes on between those two text editors. They're fundamentally different in how you edit text. But if you're a new beginner and you want to just open a text editor on the terminal and try to write and edit some files, the easiest text editor is Nano. And the reason is because by default you get put into Nano into a text editor. So for example, at nano-hi.txt, you get directly put into a text editor screen, and you can actually just start typing keys, and it'll actually reflect that, sort of like how you open Notepad on Windows. You can use the arrow keys to navigate around the text editor, and you can use the default control buttons to actually control like save or quit the file. And if you open Nano, you will actually see down below the screen there's a little bar that has helpful hints on telling you what those control buttons mean. I think like control like X saves and exits out the file or something like that, but it tells you very helpfully what that means. Whereas for something like Vim, the classic joke is once you get into Vim, and if you've never seen this before, you're never going to be able to exit out of that because there's no helpful hint. And the very core difference between Vim and some of these other editors is that Vim is a modal editor. So by default, you don't actually get to type text into Vim. In fact, by default, you are put into this mode called normal mode, which you can move around with other keys like H, J, K, and L for like up, down, left, and right. Quite confusing stuff.
Use your arrow keys.
But if you ever accidentally get into like open a text file and you don't know how to exit out of it, and you recognize that it's Vim, the way to exit out of that is to hit the escape button first, then colon, Q, and exclamation mark, and then hit enter. This means return to normal mode from whatever mode you are. Even if you're in normal mode, you go back to normal mode. Colon means enter the ED editor. Q means quit. Exclamation mark means quit regardless of maybe you've done some edits to the file. Enter returns you back to the shell.
If you'd like to try this in your own terminal, kind of at your own risk, then feel free to open up your terminal, type VI or Vim, and hit enter.
Isn't just turning off the device at this point and turning the
Yeah, so there's a joke about that. And for the people who are advanced users and who might know about Vim and know about the jokes, there's actually another text editor that I recently encountered that has some of the same design philosophies as Vim that I've never ever seen before in my life. And that text editor is called Joe. Oh, perfect. Timing. Thank you very much. And the Joe editor, I've opened this Wikipedia page, tells you that it continues to be included as an option in Linux distributions, but I had never heard of this before, and I spent 30 minutes trying to figure out what the hell I was using because it decided to just pop me into this random editor that I've never seen before. And it turns out the way to exit out of this is like pressing Control K and then pressing X, and then it somehow like pops you back into your terminal screen. So if you found all of this very confusing, don't worry. Sometimes we do too. That's the main conclusion I wanted you to take out of this. But here is how Vim looks like. So this is the standard Vim over here. You can see there's this down bar over here. In order to quit, like maybe I hit I to enter insert mode, so now I can actually type stuff over here. I hit escape to quit out of it, so now I'm back into normal mode. If I go back to insert mode over again, you can see there's an insert down the bottom left-hand corner. Huh?
How do you go to insert mode again?
Type I. Click the I button to go into insert mode, escape to go back to normal mode. From whatever mode, you can always go hit escape and it'll bring you back to normal mode. There's always things like V, which gets you into visual mode. As you can see, that's visual line.
Visual mode is like for selecting.
Yeah, and there's control V, which is visual block. There's just normal V, which is just visual. So there's all kinds of modes that you can do in Vim. But escape always brings you back to this normal mode, of which you can type colon. Colon brings you down to over there. That's the legacy ED editor. So it used to be when you were in the 90s and editing things on these very, very old machines, you would edit text line by line. And so that was when the line editor, the stream editor came. And Vim, when we had nicer screens, improved upon that and made you a nice whole page. But these commands still work, colon Q. And the exclamation mark means I want to quit that without saving anything. And I hit enter, and now I'm back to my original terminal.
Can you command plus says where's the name?
Oh, yeah.
The moment they said it had Vim tutor, I just skipped it. Like, if it needs a tutor for you.
I don't know if I have Nano on this machine. Let's see. Okay, so there's Nano. Nano, and there's Pico. Pico is like the, I think, newer version of Nano. These things should also exist on your system.
Anyone taking the glorious class known as Math 22AL?
Oh yeah, that class.
Yeah, you probably know Pico? Yeah,
Pico, yeah. So it's a text editor that works on the command line. As you can see, these caret symbols means the control key. So control R is you can, I think, select a file to read. Control X is to just exit. But by default, you don't have to hit any special I keys or whatever. You can just start typing hello, and it'll just type hello. In my opinion, these there's trade-offs, right? Nano and these are simple to use, which means they are simple in design and aren't very rich in functionality. Whereas something like Vim and Emacs, they are more rich in functionality and therefore have a higher learning curve. I think you can get very proficient with Vim. And the joke is, if you want an operating system, you can use Emacs. All right, so Control X to exit. I don't want to save anything, so hit no. So now again, I'm back to my original terminal.
And a lot of our lectures will be using Vim just because that's what we are used to. But if you're doing an assignment and you're put into a terminal and you need to edit a file, feel free to use Nano. Like, there's nothing wrong with that. Lots of people use Nano and it works well for them. Vim is just something where once you know it, it's like kind of muscle memory to get things done. So
right.
At a certain point, I mean, you can start trying it, but if you'd like to use Nano, then stick with it. There's nothing wrong with that.
Is it faster for you in any way just to use it? Or
Yes, so I think it's a lot faster. I'll edit all my text documents with Vim. In fact, I use NeoVim, a newer version of Vim essentially. And sometimes like the other cool thing about using the terminal, which a lot of you will likely be using once we get our machine set up, because you'll be using something called secure shell, which means you get a shell on your computer, so you don't get a nice graphical user interface, which means you're forced to use the terminal. And one of the key things that I use Vim a lot on the terminal actually is when I type a bunch of commands and I realize this command is actually terrible, I need to edit this command. You can use Control XE. This brings up your default editor. And so now I can actually edit my commands over here with my default text editor. So maybe now I can actually do cat file and I get what I want. And I can exit back out of here. And it brings me back to my terminal with the things that I edited. So that's Control XE. Control X, hold down, and Control E.
Well, I've never seen this before.
We're taking this class too.
So there are actually some very fancy things you can do with the terminal, and once you get proficient with that, sometimes you'll actually see me live editing things on screen with these commands, purely because navigating around this is easier, in my opinion, with Vim. The other thing is interesting is Emacs was developed by GNU. Unix is also now inherited by GNU, so you can actually use some Emacs bindings on the terminal itself as well. So things like Control A brings your cursor directly to the beginning, Control E brings your cursor to the end of the line, which sometimes makes things easier. So for example, I'm typing something, I realize I actually need root privileges, so that would require me to put sudo, so I just Control A sudo and then come back. Sudo, by the way, is substitute user and do. That means I want to switch my user to a different user. That's the su command, substitute user, and you put the username. If you leave the username blank, that means you want to switch to root, and you'll have to supply the password. sudo means you check if your current user is in the sudo group, asks if you are allowed to elevate yourself to root privileges, and then execute whatever command. So if you do sudo su, that means asking if I'm in the sudo group, if I can escalate my privileges, and if the answer is yes, then I switch to the root user without having to supply the root password.
Has anyone ever like opened an application and then you got like a prompt that says, "Would you like to run this as administrator?" or something like that?
I got it once for the CSIF, and I did sudo update, and then
So sudo is kind of the analog for that, but in the terminal. So it's trying to run something as root, so like as the administrator. So root in Linux is the same thing as administrator.
All right, I just talked a lot. Anyone confused or anything? Great.
temperature check.
How do you quickly delete a line?
Delete what line?
Like if you type a line in the terminal, you realize the entire thing's bad.
I think Control U does it. So if I do this, I think Control U. Yeah, Control U kills the whole
It
line.
deletes everything before your cursor.
Yeah, before your cursor. That's correct.
I mean, I just use Control C.
Control C kills the session. Yes.
Yeah, well, I mean, it just kills the line and then just gives you a new line.
We all have our own preference.
And then some other tips and tricks. I won't actually demonstrate this on my machine, but Control R allows you, actually I can do this. Control R allows you to reverse search the most common, the last things that you've done on the terminal. And if I start typing commands, like it will actually start searching. So maybe I want to look at the man pages. So these are the most recent man stuff that I've done. As you can see, I've actually done some research before actually teaching this. So Control R is really helpful if you want to refer back to a previous command that you typed, and now you need to use it again.
Does it work with every kind of terminal, or it's just
Most of them, yeah.
Uh,
Shell.
Any shell would work, basically, with the Control R.
oh, yeah.
I mean, it might look a bit different. Like I use Bash, and it does not have such fancy features as like recording my entire terminal history, but I can still look up commands up front.
Right, so it depends on like what certain settings. By default, I think it saves the most like 250 commands that you've typed into the history file. So the history file is actually saved in the hist file. So everything that I type essentially gets written into that file over there, .zsh history. If you're using Bash, it will be bash history. And then you can actually cat that file and see the entire history of what you've done. But of course, it starts overwriting once you've exceeded a certain number of lines. And you can, of course, set that in your ZSHRC or your bash RC file as to how many lines it's allowed to record.
This is better than just a raw for everything.
Right, so it's better than doing constantly up arrow, because you have no control. You just literally move up and up. The Control R actually allows you to put in patterns of like, this is what I want. Like I knew I had done a man command. I wanted to look at what command, for example. Maybe I've done this different awk command, for example. And the previous commands was, change directory, change directory, change directory. Not very helpful. I can just look at the awk commands. Oh, there it is. So that's the nice part about that. But Control R, man, for example, you can still use up arrows. Like you can see, like it still goes up and goes down as to the previous commands that you've ran over there.
How do you switch between the terminal and the display, or the RO just goes directly to the R section?
The what section?
Like when you
You hit Control R on the terminal.
Yes, but like once you do it, if you do a RO, it just goes up in this list. It doesn't go up to the previous commands instead.
No, it doesn't, right? Because I'm still in this Control R session over here. So now when I hit Enter, for example, now it brings me that command. And so this is sometimes that I use. For example, I know I've ran a similar command previously, so I Control R, find that command, and I use Control XE to go and edit the command inside my Vim terminal because I prefer Vim, and I edit out exactly what I want, and then put it back out, and I run the command. So that's something that I do a lot. As Jason has pointed out, you can use Control C to just kill the current session without running anything, and it brings you back out to over here. You can use the clear command, which clears your current screen, brings you back up, or you can use the Control L to also do the same functionality. Any questions here? All right. I will just keep running if no one has any questions. If you're very, very confused, please do let me know. Next thing I want to talk about is single and double quotations. So as we've shown before, you can use either single quotations to directly mirror strings over here, single quotes as well as double quotes. allow you to do the same thing. So with difference, and the answer is there is a difference. As you've seen, I had the hist file variable, and so if I put it into double quotes, it actually substitutes the variable with what was saved over there, versus if I did it in single quotes, you will see it doesn't actually substitute things. So single and double quotes do matter, especially when we get to the awk session where you will start to see $ signs all the time. $ in bash means it's a variable name, which there are a lot of. One of the classic ones is the path variable. The path variable tells you exactly where all your applications live. As you can see, there's a ton of them on my computer. It tells you all the different paths that, like, every single time I run a certain command, like this echo command, where it's trying to find this command. So it has to live in a binary at some place, and it's in one of these folders. And if I really want to know where this echo command lives, I can do which echo. It'll tell you, oh, it's a shell built-in command, so maybe a different command, awk maybe. So it's in user bin awk. At some place over here, it's probably in one of these bins someplace. I can't, oh, there. Second row over there, /user/bin. That's a place where it tries to find any of the binary files. So it always starts at the very beginning and keeps looking until it finds a binary that matches that, and then executes that one. So these are variables that live on your operating system. The dollars, and you can always change things by using the export command. So I can export on maybe a different variable. So let's actually test that I don't have, a test variable. So there's nothing in the test variable, so I can export something into test. I believe export, I think it's just test. Hi? Let's see.
I think the equal sign.
I think you need an equal sign. Okay.
Equal sign, and there cannot be a space from it.
So there you go. So that's how you write a new variable into there. And if you want to update something, like if I wanted to add something to my path, so I would export this, and then you can always do like test. So that's whatever in there, and then keep appending, hello. Oh no.
It was too powerful.
Hang on. I'll go turn it off and turn it back on. We'll see what happens.
We're going to come back up.
Well, I mean, nothing came out of the. Wait.
Oh, it's back. Oh.
Okay.
That's because I moved. No, no.
Okay. So now if I, oh shoot, that did something unexpected. That's interesting.
Do you want to put it in quotes, mayhaps?
Might need quotes. Let's see. Don't think that.
Can you just append it? Oh, let's try it.
No.
Well, I mean, you changed the hello. Now it's like .hello. So I mean, you did append.
Oh yeah, I did append it. Okay, so that's one way of appending text into the variable. Bash is notoriously difficult to work with if you want to work with variables. So always be sure what you want to change, and make backups before you make changes to some of your critical variables, like the path variable. So that's on variables. Unset gets rid of the variable. So if I unset test and echo test, now test is blank again because I've deleted the variable. That's variables.
You should unset your path variable.
Oh, if I unset my path variable, I'll have a very difficult time of doing things because a lot of commands won't work anymore.
Anyone want to think about why that is?
What'd you say?
It doesn't reset it defaultly. Like if you screw up that, you're dealing with it, or what?
So when you make these variables, they exist for your current terminal session. So if I spin up a new terminal, it will actually read from my -rc, my ZSH-rc, which contains these path variables already. So it's going to fix it if you exit out and go back again.
There's different scopes for variables, kind of like in programming languages as well. If you have like a global variable, that will be superseded. So any like local variables will take precedent over a global variable, for example, in certain cases. And so if you unset path right here, that'll happen for this terminal session. But then once you open a new terminal session, it'll pull it back again from the global, and then that'll overwrite it, and so it'll work again.
Okay, that's nice, because like, I don't know how much flexibility the next gives, so if it gives too much, then...
Yeah, there's certain things where they consider like in advance that
don't want
So if I
to-
unset path over here, oh, it doesn't even allow you. Oh, no, because I put the $sign. Okay, so now if I use something like change directory, which I don't think is a valid,
Might be a shell command.
I think yeah, you can see it's not found because, damn it. Because the change directory command is not a built-in command. It's in the /user/bin. In fact, if I kill this terminal session, so I kill this, yes, and I respawn a new one, and I do which CD. Oh, C is alias to Z. Oh, never mind. So that's why I alias that command to a different command. Ignore that. I forgot about that. Anyways, but yes, you can actually do damage, but when you kill your shell and respawn it, it will come back.
So try seeding into a directory.
There you go.
It's fine as long as you don't change the config file that it's reading
Yeah.
all these variables from.
All right. So that's variables. Some other fun stuff that you might want to know about is the fact that you can do things like tab substitution on your machine. So as you just saw, CD, I hit the tab button. It shows me all my current active, all my directories that I can actually go into, which is very helpful. So I can do, test, for example, and it will auto-complete. So tab is, some command is very helpful. There are also other things that, like, for example, I do watch date was a command that we previously ran before, I believe. So it just keeps, refreshing this. I hit Q to exit out of that. I can actually execute this in the background with the ampersand symbol. So now, as you can see, it tells me that this command is still executing on my machine, but in the background. And if I use the job command, or jobs command, it will tell me that there's one suspended process that's running on my machine, and that's the watch date process. I can bring it back to the foreground by using the FG command. It brings it back, so now it's back over here. Q to quit out, and now if I go back to jobs, it tells me there's nothing that's actually running behind. Other things that are,
Because you hit Q and closed it.
Yeah, because I hit Q and close it. The other thing that you can actually do instead of using this direct background thing is you can come over here and hit the Control Z button, which brings you, which puts the job into the background and suspends it. And again, I can go foreground. And if you have multiple background jobs, then you can specify the number. So maybe 1, 2, 3, maybe like 500, background process. I can just bring it back up. So FG1. Oh, you have to, I think, do like that. But by default, that's the first one. I can bring it back up like that. Other things that are useful is if I go back to this watch date command, and then maybe I actually want to execute this with sudo privileges, I can actually do sudo and then do bang bang. The bang bang is short form for the previous command. So if I hit that, you can see it just replaces that with the watch date. Newer systems actually put this out for you to edit, but legacy systems will just execute that command. So that's a very useful thing. There are some other extra variables in the bash. For example, the $? tells you the return code of the previous program. So if you ever wrote a C program, you say return 0, return 1, that's the return code. And sometimes these return codes give you helpful information for debugging purposes. So that might be helpful at some point.
0 returns a success, but a program might fail or give an error of some sort, and it'll return something that's different than 0.
Correct. Wildcards exist, so if I want to, let's go back to the touch command, and you can actually do, so let me, I do test 1, 2, 3, 4.txt. So now if I look over here, I may touch 1, 2, 3, 4. So that brackets allows me to rapidly expand things out. Maybe I also make some other file. Hello 1, 2, 3.txt. So the reason why I did this is because now I can show you, maybe I start removing some files. I only want to remove the test files and not the hello files. I can use test asterisk. The asterisk means match, just like our regular expression lesson just before, matches anything that has test and then anything else. and hit enter, that should remove all the test files, and now you ended up with only the hello
This is a
files
bit-
left.
This is a bit different than a regular expression because remember, well, actually, just a question for everyone. If you wanted to make a regular expression to just match text number.txt, what would that look like? Or
What was the question? I'm sorry.
if you wanted to make a regular expression that just matches test number.txt, kind of like these, what would that look like?
And not test with anything afterward. Like
Yeah.
if I say test, I don't know, desussy, you don't want to hit test desussy.
So you test number, arbitrary number of numbers, or
Yeah.
Okay, you do test as it is, and then you add the set thing
Yeah.
for 0 to 9, and then you put plus for that because you want one or more.
Right, so
And
the problem with what I just did with that asterisk is if I had this test.txt and I only wanted to remove the ones with the numbers, I'll actually remove the test.txt as well. One way you can do that is you can use the ls command, type this into grep, which supports regular expressions. So let's try this test. And then I only want a number from 1 to 4, .txt. So if I run this right now, it will show me these are the 4 files. So I can just pipe this into the remove command. You might need xargs, rm, to put that into the rm command. And then now, if I just do ls, the test will still remain there.
So the command here that Ethan showed here is a little bit different than a regular expression, because if you're interpreting this as a regular expression, then you're saying rm test t and then star. So the star is a quantifier, right? It means you can have any number of something, and then it's specifically looking at t. So it's basically matching anything that looks like any file that's called test, or test with a t, or test with more t's,
Right.
infinitely many times. So it's not the exact same as a regular expression, and maybe that's a bit confusing, but generally, if you have an asterisk just by itself, commands will interpret that as meaning any character or any number of characters. So in regex, a star means it just means any number of characters. But if you're looking for files, then it generally means any character any number of times. Does the distinction there kind of make sense, or is it a bit confusing?
Okay,
Yeah.
yes.
It's just a question about grep. When you use like the dash e for regular expression.
There's certain. Do you want to answer that?
The dash e for grep.
Yeah.
So the dash e for grep, let's read the exact manual. It's extended regular expression, so it supports more features. I think that then actually matches your typical PHP grep, PHP regular expression support, which I actually don't really know what the difference is. Usually you just use the dash e for maximum compatibility, but for small things like just the regular sets, I think like the thing that I showed like this over here, that I think is only supported with the extended regular expressions.
For the assignments, we do suggest that you use dash e. I
If
we
you
might
ever
have-
need, yep.
If you need it.
I'm sorry, what was the slash d?
Oh, the slash d expands out to 0 to 9, the set 0 to 9.
This also is supported in sed. So in sed, you can also do sed-e, and then you can match by regular expression, or extended regular expressions. So
Yes.
Does egrep be deprecated?
Is which one?
Like egrep, putting e before grep.
I think that just showed you the egrep is essentially retired, right? Because we can use grep-e. It might still exist in our system, I'm not sure.
Is it not just an alias? Or?
It might be an alias, let's see. Egrep. Yeah, it's alias to grep-e. All right, any other questions? One more thing about, or two more things about bash that we should talk about is process and command substitution and input-output redirection. Process substitution looks like this.
oh, we did redirection.
Sorry, process substitution looks like something like this. So remember the cat command, cat shows what file is, like what the output of a file is. So if I had this test.txt, there's nothing. So maybe I should write something in there with vim, hello. And maybe I'll also use hello.txt, or just tx, I guess. Hi. So if I cat two files together, it concatenates them. .tx. I thought I just edited that. Oh, because it's did I not? Oh, maybe I didn't save that. Hi. Okay, there we go. Hello.txt exists now. So if I cat this, it will show hello, hi. Maybe I actually wanted to make a new file, but I don't actually want to make a file. One thing I can do is cat test.txt. The command substitution basically takes the output and turns it into a temporary file that allows you to put it into a command. So something like echo hi. Actually, let's make it different. So echo akhil. So now this process, whatever is inside this angular bracket, this I put in any regular command. Whatever the output is gets turned into a temporary file. By default, I believe it's in your /dev/fd. So that's a file descriptor with some random number behind it. So that becomes a temporary file, and then that gets put out. So that's one way. If you wanted to make a temporary file on the command line, it will get deleted after this command is executed. There's something else that you can do. For example, echo, and I actually want to do something else. I can use this $sign. This is a command substitution, so I do something with different commands. For example, I can do, what's a good, let's just do 2 echoes at this point. Echo hi. So this says take the output of the command that's inside this $sign symbol and take the output and just place it into the command line. So the difference between those two is the first one with the angular bracket, whatever output gets turned into a temporary file. The second one with the $sign, the output that gets executed is directly just put onto the rest of the command.
If you want to see like a...
Didn't it have for the first time hello and hi, but for the second one it had hello akhil or something?
Oh, because you mean the difference between these two?
Yeah.
So this one, because hello.txt itself has hi, therefore when it concatenates the 2 files, it has hello and hi.
Oh, my bad.
But the second one, because I created a new temporary file with the output of that command, echo akhil, so that command itself essentially saved to a temporary file called /dev/fd/whatever, and that file itself has the input, contains akhil, and so when I concatenate them, they have that hello akhil.
Just some more demonstrations, you mind if I...
Yes.
When you say it's a temporary file, does that mean it's only during this like bash instance that it exists, or like would it?
My understanding is it actually gets rid of it, so I can actually show you. So like export this test variable, and we can do something like echo akhil again. So this, what it should do is it should take, again, because whatever that angle thing is, it returns this temporary file descriptor. So if I export this over here and I echo test, you can see that the thing that got saved there is this /dev/fd/13. So now if I actually cat that file out, let's see, bad file descriptor. So the moment the command itself finishes running, the file itself gets deleted. Any other questions? Yes?
Why would such a thing be useful for?
Why would this be useful? It's not useful until you get to a situation where you're like, I actually want to use something like that. Sometimes I do come across like there are these different commands that I want, and I want to say instead of using these basic echo commands, there's another file that I might want to put in and manipulate something first before passing it in as an argument. So that's when that might be helpful. $sign is also helpful. Sometimes I want to execute a command within the command, and so that's when the $sign is helpful.
I have seen one case I remember that it was used was, I was running a command that accepted a log file as an input, and the log file was just made up of numbers, any number of numbers, so it could say like 100, 200, 300, 400, any numbers were inside of it. And so the person who was writing this post just wanted to pass in a very simple log file that just contained one number. So instead of making a file, storing their number inside of it, and then running the command they wanted to run, the log analysis command, they just ran the log analysis command and passed in a temporary file that just put in 100. So it was just to make things faster, just have it in one line.
Oh.
And it makes it easier to read too, because then if somebody's looking at this post, like if I was reading this post, then I know, okay, they're just making a temporary file that just has 100 inside of it, and I'm not seeing that they're like opening Vim, storing 100 in it, and then exiting, and then running a command.
And again, like this itself automatically cleans itself up, right? You don't actually create a new file, and you have to now worry about deleting it. So that's the nice part about this. Last thing about Bash that I want to talk about is input and output redirection. And that gets confusing once we've talked about this whole, oh, you talked about that?
Thursday, yeah.
Okay, so the key thing is you might remember that input-output redirection also uses this angle bracket, which again looks like what we had with the process substitution. The difference is process substitution, you must have a bracket with no space in between it, and otherwise you use your typical, like that. So that's you're allowed to have spaces in input-output redirection. Hopefully there are no more questions there.
We talked about it on Thursday, but did anyone have any questions about it, or like try it afterwards and have questions that came up about redirection?
So there's a lot of redirection. If you go back to the website, I put some very interesting posts over here. So you can see you have all of these are allowed input-output redirection. So you have these named file descriptors. One is for standard in, 2 is for standard error. The ampersand is for standard input and standard output. You can do things like this. So I can output a file like echo something into ampersand 2. So now whatever output now gets fed into the standard error file, versus if I just did 2, that actually outputs to the file called 2. So things that might be interesting. All right. Any other questions about Bash? All right. So now we can talk about awk. Awk is a very useful command in my opinion. Awk stands for Aho, Weinberger, and Kernighan. Those are the 3 people who made this utility. For those who might be familiar with Kernighan, sounds familiar, that's because he is the same Kernighan as Kernighan Ritchie for the inventor of the C language. And so you might realize that a lot of the syntax that applies in this awk utility looks pretty similar to C, because one of the authors literally wrote the C language. What else do we talk about? Okay, so awk is actually a Turing-complete programming language, so it could be used for a lot of things, but the most useful thing that people use awk for is for parsing column-aligned text. So when you have something that has a bunch of columns in it, that's when it's most useful for. And that's why if you look at the PSAUX command, this is pretty useful for piping into awk, because as you can see, there are a bunch of columns, user, PID, %CPU, %memory. These are all separate columns, and it's easier to take output from a command like this. All right, so how do you use awk? Awk essentially has this form. Your programming language just takes in this pattern with the brackets action. The pattern is allowed to be a regular expression pattern, hence why we talk about regular expressions. Very useful. You can match a lot of different things, and you have the $sign to match the different fields in the different columns. By default, the different columns it recognizes are separated by some amount of white space. You can change that with the -f command. So if you're parsing something like a CSV file, which is a comma separate value file, you can do -f comma, and it will parse it by separating the text based on commas instead. So how can we use awk? The easiest thing is let's just do something like PSAUX. I was going to do this with SS. I don't think I have SS on here. SS is not found. Netstat. Do I have netstat? Okay, I have netstat. Okay, so let's use netstat then.
So feel free to try running that on your own laptop. It'll show the ports that are open on your computer right now, or listening. Any programs that are opening ports, basically.
So if you are running Linux, netstat has been deprecated in favor of SS. But for those that don't have SS, as you can see, netstat should be on here. Netstat tells you all the active internet connections, receive queue, send queue, tells you how many bytes you're receiving, how many bytes are waiting to be sent off. There are all these fun stuff. Sometimes it tells you information about what is being run on your computer. So this is helpful for security applications of diagnosing what is going on with a particular machine. Maybe there's an actual attacker that's coming in, and you might be able to actually see from the foreign address or sockets what is going on. So as you can see, I have columns 1, 2, 3, 4, 5, and 6. 6 columns over here. Maybe right now all I care about are my local addresses. What's running locally on my computer, so I want to just isolate that, so that's the 4th column. So I will do netstat, and I'll pipe this into awk. And right now, all I'll do is I'll just do print $4. That's hopefully that does what I wanted to do.
You might want to put it into a file first.
That's a good point, because okay, so let's actually just netstat and pipe this into head. Let's just take the first 10 lines. I'll put this into netstat. Let's just call that. What do? Netstat's taking forever. Oh, that's because I wrote that command wrong. Or it'll just take forever.
You could T it as well.
This was not good. T.
You can remove head after that because there's no output.
This doesn't work.
Oh, that's so weird.
What happened to my netstat command? It's running.
Is it printing to change the output, or is it just...
It is, yeah.
I think it is.
Can
Why
you
is
just
it
copy paste it too? I know that's like cheating.
Okay. I don't know why it decided to hang on me. Okay.
maybe give them like...
This whole thing is broken. Okay. We'll just kill that terminal session. And let's do this. All right. I'm just going to copy some of this output because I don't know why it doesn't want to do what I want it to do for now. All right. So let's just copy that output. I want the dictionary. Paste this in. That's that. Okay. Okay. Hopefully that's there. Okay, netstat's there. All right, so let's come back to over here. Netstat, some portion of the command is over there. So let's just cat netstat, pipe this into awk. I set print $4. So that should hopefully give me only the 4th column of text. And indeed, it does. As you can see, because it parses by space, it treated local and address, foreign, address, and state as completely separate things.
So if you looked at like the 5th column, that would be the word address right
Yep.
after the word local.
So there are some quirkiness with that, but for the most part, when we talk about data, we don't really care about the headers. So that's something we can do, is just get rid of that first line, and we'll talk about how that works later on. But now we come back to this pattern awk print 4. What does that mean, and why does that work? So if we go back to the man pages for awk, you saw you require a pattern, then you require an action. Missing pattern always matches. So what it does is whatever pattern there is, if it's true, you execute the action. But because I missed a pattern, so therefore that line will always match. So the pattern applies on a per line basis. Now, if I wanted to match a particular pattern, maybe this pattern is that, I forgot what the netstat looks like. Maybe it contains the state established. So we'll try to put a regex in. Hopefully this works. Established. So those, did that work? I don't think that worked. It's too many for established. How many are these? word count 15. If I didn't do this, it's still 15. 23, so it did. So it filtered out everything that was not established and only printed the ones that had the pattern established into the output. So that's an example of a pattern. Oh, and you can see very clearly that it worked because the local is now gone because the first header line over here doesn't contain, that very first line over there doesn't contain the word established. So we filter out now everything that's only established. These are the local addresses that I have. So that's an example of a pattern. There's some special variables in awk as well. So you can still apply, within the statements, you can apply things like for loops. So maybe you filtered something out and you want to start counting things. This example is a pretty good guide, in my opinion. So you have some special functions like you can make sure print lines that are longer than 72 characters by using the length function. The print by default is pretty easy. You just print $signs. If you want to use more advanced things, there is printf in here because, again, it's written by Kernighan. So printf still is supported with the standard template. Special patterns have begin and end. So begin means that this command, whatever is inside that action, is executed once at the very beginning of the program. The end means this particular statement is executed once at the very end. For everything else, it's executed on a per line basis based on whether or not it matches the pattern. That's the overview of what awk is. Any questions so far? I think that's what I wanted to cover on awk. I can double check. So I put these are the helpful, there are some special variables. If you use $NF and $NR, that means the number of fields that are parsed on the current line. The fields being the number, essentially like number of columns. And R means the line number that it's currently parsing on. So if I wanted to filter out, for example, the first line over here, I can just do only match it if NR is greater than 1. So now, NR is greater than 2, I guess. Would that do? Okay, there you go.
There were 2 lines at the top.
There were 2 lines at the top, there you go. So it killed the first 2 lines at the very top, and only after that you can print the rest of it. So that's one way to get rid of header information. Huh? Lines and rows are the same thing, right?
Generally, awk is one indexed, I believe. So instead of like
yes.
C programming or Python programming, where you're indexing arrays starting with 0, you're indexing starting with 1. So just now, Ethan did NR is greater than 2. The first line was indexed 1. The second line was indexed 2. Third line is indexed 3. We want to start at 3. Rather than starting with like C, for example, if you have an array, then it starts at 0, 1. So if you want to get the second and below, you would say greater than 1. Here you're saying greater than 2.
And so that's why like the fourth column is actually $4. $0 means the entire line.
And there's also lots of features in awk that you can find from other programming languages. Like it has for loops, it has if statements. So it looks similar to any type of programming language. It's just the syntax is a little bit different. Yeah. Any questions?
And then so when you want to combine multiple statements together, that's the other thing that I should talk about, is you can use a semicolon, and this is allowed in your homework assignments.
For the one question
For this one question, because we're allowing semicolons within the arguments of any commands that you run, just not out of them. So you would do something like this, and then maybe you have something else that you want to print out too. So now maybe I also run the established thing that I just talked about. If I spell this right, established. And then I, also print $6. So they should all show established. So there you go. So you can see every single line it executes. Now I can see that that first line clearly is not established. The second line is. So therefore, both conditions ran.
Just note that there's only one part of the homework assignment. I think it's 2D
Yeah, so question D allows you to use awk. The last question, I believe, you're also allowed to use awk.
But the other parts do not allow it.
The other parts do not allow you to use awk. Any questions? Okay, so this actually essentially concludes our 3 command line and terminal lectures. This should be enough for you to complete your homework assignment. I have on the website included a list of reference commands that I think might be useful in general. We have 10 minutes, so I will try and quickly go over and give you all a refresher of what every single one of these commands do. Some of them we haven't covered in class, so if you want to know in more details what these do, you should use the man pages. All right, so if there are no questions, I'm going to try and hurry and try and cover, I don't know how many commands there are. I think there are like 50 commands. All right.
30 seconds each.
We'll try. The archive command, or the tar command, takes a bunch of files and puts them into one file in the .ar or .tar format. The awk command we just covered allows you to parse text in column format. Base 64 takes text and turns it into base 64. It also allows you to use the -d command, the -d tag, to turn base 64 back into non-base 64 things. BC is the basic calculator. BG and FG is for backgrounding a task and foregrounding a task. Cat concatenates a file and prints it out to the screen. Chmod takes a file and changes its permissions. Clear clears your screen. CP allows you to copy files or directories from one place to another. Curl or wget allows you to fetch websites from the command down to the terminal. Cut allows you to manipulate text with delimiters. Date shows you the date and time. df or du tells you disk free or how much your disk has used. The diff command allows you to differentiate between files, shows you what the differences are. The dig command outputs information about metadata about a website. I don't know how better to describe that. You should look at that. Echo prints text out. The file command looks at the magic numbers of a file and tells you what type of file it is. Without using the extension information, because you can wrongly name extensions for different files. The find command allows you to find a command, not find a command, find a file on your disk. The FMT command allows you to format text in a certain way. The fold command, I forgot, so look it up. The GDB command is the debugger, the GNU, whatever debugger or goddamn bug, I think is the other name for it. The git command allows you to use git. The grep command we talked about allows you to search for text in files. The gz command is a compression library. The head command shows you the top n number of lines of a file. The hex dump command takes file and outputs in hex notation. The id command shows you the ID of your current the users that are logged in. It's your current user ID. I think I should be able to run this on here, give a demonstration. So this shows me all the groups I'm in. So like I'm UID 501. If I'm root, I should be 0. The join command joins different texts together. The kill command kills programs. The less or more is a pager, so it outputs into a nice little page, so you can do scrolling on a terminal essentially. ls command lists files. The ltrace command traces programs. The man command is a man page that you should use for all of these commands that I'm listing over here to figure out what they're used for. The mv command is a move command, moves a file from one location to another. It can also be used to rename a file. The nc command is netcat. It has to do with networks and moving data from one network to another. That command is not opening an encrypted tunnel. The passwd command changes your password on the system. The paste command does something related to cut, join, and all of that, so you should look at that. The perl command, we didn't talk about the perl command, but I suggest you look at the perl doc, perl intro. This is a brief introduction overview of perl. I suggest you read the thing. You might find it useful in later assignments. The ping command is pretty intuitive. You just ping a different machine and it tells you whether or not you get a response and what kind of response it gets. Printf command is like the C command. It prints text. The PS command is the process command, lists all the processes on your system. PWD command is print working directory, tells you where you are in the file system at your current location. The RM command removes files. The sed command does string parsing. The SEQ command prints a sequences of numbers. The SFTP, TFTP, and FTP is file transfer protocol command. So there's the secure file transfer protocol, trivial file transfer protocol, and the normal file transfer protocol. Sorts stuff, splits text, SSH and SCP. Useful when you are starting to do your assignments. It's a secure shell, so it opens up a secure tunnel between your computer and a destination computer. SCP allows you to open a connection just for copying files. The stat command, I think lists statistics about something. I can't remember what statistics it lists, but it lists statistics about something. Strings command outputs binary, takes like binary information and tries to find all the applicable ASCII strings it can find. The SU, substitute user, and SU sudo escalates permissions or switches you to a different user. The sum command sums things. The tail command outputs the last X number of lines of a file. The T command takes files from one input, puts it into a file, and also outputs it to standard out. Time command times how long a process is, not displaying what the current time is. The tmux command is a very useful command. This is what I've been running this entire time on my terminal. That's why I have multiple different shells on here, so I can easily create new shells, close new ones, and does a lot of other cool stuff. The touch command creates a new file if it doesn't already exist. If it does, it updates the current the time of last access to the current time. TR command truncates things, true or false, just spams true and false on your terminal. UMask command, I can't remember.
Like
Hidden bits or something like that. Uname tells you what your current machine type is. The unique command asks how many unique things are in a list. VI, Vim, or Nano are text editors. The W command lists all the users on your computer. The watch command takes another command and keeps re-executing that. The WC command lists the word count. The which command shows you where your command that's being executed lives, where the binary lives. Who am I tells you who you are on your computer. Who is tells you what domain name registrar information there is. Xargs takes piped input and puts it as an argument at the end of your command. The S command keeps spamming Y. You can change it to something else. The zip and unzip command zips files and unzips files.
Time. 7 minutes, 37 seconds.
That's it. Hopefully you all enjoyed.
You name it.
That's just like last minute because about
System
Tally
information.
stuff.
System
Has
information.
everyone had a chance to take a look at the range connection instructions? Does anyone here not know how to use SSH or has never used it?
If you haven't, come to us in office hours and we'll show you.
Yeah,
Or
but
Discord.
then I'm not going to include the exact commands in the connection instructions, but hopefully they are. If you have any questions, just feel free to ask. I'm still deploying the ranges. 200 minutes is not 2 hours; it is 3 hours. So I'm like barely halfway through deployment. So I will send a ping in Discord once they're all up, and you give it a try. If there's any issues, again, just bug us about it. All right. Thanks for
Take
coming.
care. Our next lectures will be about
OSINT.
open source.